Well, hello out there in YouTube land. This is my documentation, my video documentation for my motor controller. It consists of 6 MOSFET transistors, the FDP3205s, and I have all of the drains hooked up on this side of the motor. So all the drains are connected to this, and then I got a big copper plate on the circuit board for power, and then on the other side of the board I got all the source pins, and I've got the gate driver. The gate driver is a MPC 1407 and its associated components, just basically 2 capacitors, and then that fires the gate of the MOSFETs, and the MOSFETs are set up with a gate resistor, 150 ohm, and in parallel with that there's a Schottky diode SB160, and this is kind of the schematic right here. I don't know if that's readable, but essentially I have 6 of them, and the way I'm going to use this is I'm going to use 40 amp relays to change the direction rather than using an H bridge. And this is going to be controlled by the PIC chip, which is a 16F628A. I've got a button on here to where I can turn it on, it ramps up, and then when I let go of the button, the motor stops. So it just gives me pulse width modulation into the MPC 6, and then that drives all the gates. And like I said, the gates are 150 ohm, and it also has a Schottky diode. And now I will give you a quick demonstration. I'm going to power it with 2 kind of small batteries. They're lawn tractor type batteries. They're 365 cold cranking amps a piece. I've got them in parallel, and so I'm going to disconnect the charger so that I can get an idea of what it's doing. That's the voltage right now on the batteries. And so I'm going to go ahead and connect it. And I realize this white wire is coming up to feed the circuit. You can see the light is on, and it's ready to give out some pulse width modulation. I'll try to do this with my one hand, and the motor is actually down here. It's a wheelchair motor. I believe it's worm drive, and I think it's about 150 to 200 watt motor, but it's a 24 volt motor, and I'm going to be using 12 volts, so it's going to be derated quite a bit. Well, let's see what happens. I got the button right here, and when I hit the button, it turns like a charm. And then what I like to do to give it a stress test, got the MOSFETs over here, and I'm going to bring this out, and I'm going to try to make it so that I can't turn this pulley. I can't stop it, but I'm going to just give it a little bit of stress. Okay, here we go. I'm going to hit the button. See, I got a ramp up, and then here's the MOSFETs. And so what I want to do is I want to show you what it looks like through the thermal camera. Try to see if I can. Right now the battery is still okay. It does eat up the battery quite quickly. Gonna need bigger batteries, that's for sure. Yeah, now you can kind of see it. It's not really heating up that much. Of course, it's killing my battery. Probably tearing up my shoes. 77. I'm trying my best to keep this. Trying to keep it from moving. I can smell my shoes cooking. Well, anyway. So right there, it seems like in the third MOSFET, it gets a little hotter than the rest of them, but actually not so bad. I kind of put a piece of paper around it so I wouldn't get reflections. I'm getting heat reflections all over the place. But I think it handles it pretty well. The heatsink is basically just a chunk of aluminum, and it actually works pretty good to dissipate the heat off of the MOSFETs. Alright, one last try. I'm going to see if I can heat these babies up. Alright, here we go. Sorry, okay. So we're at 73. Alright, this is just too hard to do. I need a better way to try to... Alright, so this is pretty much where it got to. I mean, and it cools down really quick. And I'm kind of wondering, when I get a bigger battery in it, you know, will it heat up quicker? I'm going to get my feet around this pulley, try to see if I can make it so the motor won't move, or at least slow it down to give it as much stress. Here we go. 78, 79. Yeah, I think it's going to do okay. These MOSFETs are just barely working, and they're not stressing out at all. They feel cold. Yeah. Alright, so I'm going to run outside. I'm going to show you what this is for, why I'm doing this. So, be right. So this is what I'm targeting my MOSFET drivers for. So, most wheelchair comes with 2 motors. So this is the second one. The first one is in my basement. That's the one I was messing with. So it already has a sprocket on here, number 40 chain, and it does actually work pretty good with 12 volts. It just seems to me that the battery was going down too fast. So I'm not sure if this is going to work. I may have to put a larger sprocket on the axle to give me more torque, because it's really having a hard time pulling it. And it is kind of heavy. It's damn near 100 pounds, so I've taken everything off of it I can possibly take off, and now I pretty much need to make some kind of a shelf or something up on top of the main frame, because the frame is like a tubular frame. It makes it real difficult to try to build on it. You can see how I mounted the motor. I mean, it works pretty strong. I mean, it doesn't flex that much. So I'm kind of hoping I can make this run around my field back there. Oh. And I want to be able to go all the way in the back of the field. It's about 600 feet, and drive my creation around the field. And that's where I'm pretty much just started with this project. I've got a long ways to go. Thanks for watching.